All right, everybody. Thank you for all the support we've been getting with responses and questions that you want answered in this time. Today's question that we had is, why do stars twinkle? And it's a question that comes from a great public school teacher friend of ours. So we figured we'd take her question and give you some answers. The twinkling of starlight is a phenomenon called scintillation. That's what astronomers call it. Now, when you see a star, it's almost the same effect as if you would see a pinpoint source of light. That starlight comes, and as you look out into the night sky, you might see it actually twinkle a little bit. So what's actually happening when that light twinkles? Well, that's a phenomenon called refraction. As the light from that star travels through the Earth's atmosphere, a change in temperature, a change in the density of that gas can cause a change in how light travels through that material. We index that with something called the Index of Refraction. For something like water, it's 1.33. For something like air, it's something like 1. For really highly polished optical glass, it's like 1.5. But that gives us a measurement in a way of how light changes when it goes through that material. So what is refraction? I guess I'll probably have to show you a demo for this. Ooh. All right, so I came in here because it's a little bit darker and it's easier to show this on the optics board. This setup that I've got here is my optics board. We use this in first year when we do the sections on optics. And I've got a setup here where we've got a laser ray box. And the nice thing about this whole setup is that if I pull this out of the way, you get these beams of light coming in. Now, these beams are just like starlight, where you get these pinpoint sources of light, right? And they're traveling through the air through a fairly singular index. But this piece of glass is going to represent this idea of going through a pocket of the atmosphere where there's different temperature or different density. And if I do that, what you'll see is that that light actually bends. And as light bends, the amount that it bends is something measured by something called the Index of Refraction. Now, so you see we've got these deviations now from the original path that the light was taking. So picture this. You've got outer space, light's coming from it, it strikes the Earth's surface, and it passes through the atmosphere of the Earth itself. And the Earth's atmosphere is full of all these regions and pockets where these changes in this density are taking place because of heat, because of wind, because of variations even in the gas that makes up the atmosphere. And that path difference is just changing a little bit and a little bit. So when it comes into your eye, it's actually hopping around on the photoreceptors in the back of your eye on the retina. Your retina has a bunch of rods and cones on it which detect light. And so that light, that beam of light that comes in from the distant star is actually just bouncing around on the back of your retina just by a little tiny amount. And that's what makes it look like the light is actually twinkling. So, back in the office now. So here's my question to you. That's what scintillation is. That's why stars twinkle. My question is, do planets twinkle? When we look into the sky and we see planets, do they twinkle? Does light from the moon twinkle when we look into the sky and see that? Can you explain why? If you can, write down in the comments there what you expect to see and the explanation behind it. Also, another question. If you were in outer space, would the stars still twinkle? Write what you can in the comments and we'll talk about it tomorrow. All right, everybody. See you later. And don't forget,